Okay, so starting with our summary, in this lesson we tackle some story opportunities, that is, word problems that lead to quadratic equations. A box with a square base and no top is to be made from a square piece of cardboard by cutting 4 inches from each corner and folding up the sides as shown in the figure. All right, so here's our little demonstration. So roughly a square piece of paper here. We're going to take this thing and we're going to cut out 4 inches from each side. Okay, I'm not going to cut out 4, but I'll try to cut out maybe 2. So we're going to cut out little squares from each of the corners. And once we've done that, we'll be able to fold up the sides and turn our little 2-dimensional piece of paper into an amazing 3-dimensional box with no top. Like so. Magic before nothing up my sleeves. Just like magic, right? All right, so everybody understand the idea? Cut out 4 squares, fold up, make a 3-dimensional box with no top. The box is to hold 100 cubic inches. Now this box holds a lot less than 100 cubic inches, yes? So the question is going to be, how big a piece of paper should I have started with so that when I fold up and cut out those 4-inch squares on the corners, will it hold exactly 100 cubic inches? Okay, that's the goal. That's for you. Okay, part A. First step is to introduce a variable. We're trying to find the dimensions of the original square, so how about we let b equal the length of a side of the original square before it's cut. And again, we'll include units. In this case, it's inches. So let's label. I guess that means that we're saying that, oh, goodness. I guess that means we're saying that this distance from here to here before we make our cut is b. Okay, and it's a square, so it's also b along the other edges. All right, the box is to hold 100 cubic inches. What math word are we talking about when we say 100 cubic inches? It's the volume, yeah? So this problem apparently has something to do with the volume. So it sure feels like we need to know the volume formula for a box. In English, what's the formula for the volume of a box? Length times width times height, yeah? Okay, so that's written down below. Volume is length times width times height. All right, so let's think about those dimensions for this particular box pictured at the right. This 4 is one of the dimensions. Is that the length or the width or the height? That's the height. Okay, so that means that the height is 4 inches, but the length and the width depend on how big a square we originally had. Now think about the fact that it was originally b, and this guy right here is what becomes the length when I fold it up. By that would be this length of the box right there at the top. The whole thing was b, but then I cut out squares from each of the corners. So how much is left for this black length? Or minus b seems reasonable. Other thoughts? B minus 8. That's it right there. The whole thing was b. The blue thing is b. Then you lose 4 here, and you lose another 4 here. So we've lost 8 altogether from the b that we started with. So this thing right here is b minus 8. And by that, that's the length. But then if I look at this distance right here, I'll use a different color. If we look at this distance right here, which I think is this guy up here, what's the expression for that? That's also b minus 8, and I guess that's what we might call the width of the box. So I think we've got our 3 quantities now, the length, the width, and the height, and we're supposed to multiply them. So I guess what we're saying is that the volume is the length, which is b minus 8, times the width, which is also b minus 8, times the height, which we said was always 4. And in this problem, we're given a goal for the volume. What did we want the volume to be? Wanted it to be 100. So there's our formula. 100 equals all this stuff. So there's the equation we're trying to solve. And if we can solve that equation for b, we'll know what the size of the original square should have been, so that when I cut out those corners and fold up, I'll get the box to hold exactly 100 cubic inches. Okay, the smart thing to do at this stage is to divide both sides by the biggest number that you can, which avoids fractions. What is that? 4. Both sides are divisible by 4, right? We just get rid of it on the right-hand side. Left-hand side would become 25. That's the clever way to do it. We're going to leave the 4 in there just in case you don't see that, because I want us to make sure we can handle it even if we don't get that. We don't see that trick in the beginning. So b minus 8 times b minus 8. This is a lobster claw or box or foil, whatever you want to call it. So ultimately, I think it becomes b squared minus 16b plus 64. You okay with that? 4 is just hanging out, waiting for you to distribute it. And so we distribute that 4 through 4b squared minus 64b plus 256. And now it's starting to look familiar. It's starting to look like problems that we have solved already. That is a quadratic equation. In order to get it in standard form, what do we need to do? Equal 0, right? And we'll do that by subtracting the 100. So 0 equals 4b squared minus 64b plus 156 after subtracting that 100. Okay, you're welcome to jump in with the quadratic formula here, but you definitely want to make your life easier by factoring out the greatest common factor first. What number goes into all 3 of these? 4. It's the 4 that we could have divided by way back when. So even if we didn't see it then, this is an opportunity for us to see it. So we factor out the 4, 64 goes down to 16. 4 goes into that how many times? So 39? That's right. And so if you want to do the quadratic formula, do it on the thing in the parentheses. Numbers are a lot smaller than they were in the previous line. It turns out this guy actually factors. I'm not going to take our time here factoring it. I mean, I'll just write the answer. But if you do your 2x2 box method, you'll end up getting the factors of this guy are b minus 3 and b minus 16. So, sorry, b minus 13. There's work involved in that line, but it's work that you've done before. It's nothing new. You can verify that later. And now that it's factored, we can take each of our pieces and set them equal to what magic number? Set them equal to 0. B minus 13 equals 0. What about that 4? What's that? Yeah, you can set it to 0. No, I mean, don't ignore it, but you set it equal to 0, and you ask yourself, are there any values of b that make this equation true? And the answer is no. So it just doesn't give you any new solutions. Whereas this guy gives you what value for b? Yeah, so here we get b equals 3. Here we get b equals 13. Over here, this equation has no solutions. It was considered and then ignored, as opposed to just ignoring it from the beginning. Okay, so we get 2 answers. So apparently, if we started with a square piece of paper that was 3 inches by 3 inches, or 13 inches by 13 inches, then we can cut out the corners and fold up in it and get our 100 cubic inches. Yes? There's a problem with one of those numbers. What's wrong with 3, Abby? We get a negative. Remember, we're cutting out 4-inch squares on each of the corners. If your original piece of paper is only 3 inches long, you can't even cut one of those squares out, let alone 2. So what's going wrong here? Well, the fact is, if you go back to your original equation, this one right here, like we really do need to make sure that that equation, so the equation is going to work for all of the solutions that we got, for both 3 and 13. But we need to make sure that our solutions make sense. And clearly 3 does not make any sense in the context of the problem. But the algebra didn't lie and we didn't make a mistake. If you plug in 13, that was one of our answers, right? 13 minus 8, 13, oh, sorry. Yeah, 13 minus 8. What do we get in the parentheses? 5. 5 times 5 times 4 is 100. 13 works perfectly well. If instead we tried 3 for those b's, right? 3 was our other answer. What do you get in the parentheses? -5, which is a problem for the paper. But what do you get when you multiply together? You get 100. So again, we didn't make any mistakes. The algebra didn't lie to us. But anytime you're doing one of these contextual problems, one of these real world problems, you got to make sure your answer is reasonable. And 3 is not reasonable even though it solves the equation. Okay? So I think, let's see, so that's there. And then on the next page, it says that b equals 3 gets rejected. B equals 13 is the only solution. Questions on that? Okay, so in the time we have remaining, why don't we start the activity on the next page? Like I said, it is a very long activity, so we're going to have all of next class just dedicated to the rest of the activity, but let's see if maybe we can get this first problem done in the activity today.